Hey class, today we're going to be learning about trigonometric functions of any angle. So we're going to use a lot of trig here, and we're going to talk about a lot of the things we saw at the unit circle yesterday as well. So we've talked about the sine, cosine, tangent, and the reciprocal functions before. If we think about on the unit circle lesson, I told you guys that the cosine of theta is the x value and the sine of theta was the y value. But really that's only if the radius equals 1. So if we're not in the unit circle, the unit being the radius is 1 unit, if we're in a circle with any radius, not 1, we actually have to follow these rules here. So the sine of theta is y divided by the radius. The cosine of theta is x divided by the radius. And then the tangent of theta is y over x, which is actually the same as it was in the unit circle. All right, so let's look at an example here. Let P be the point, -3, -5, on a graph. So the first thing I'm going to do is I'm going to draw that graph. So -3, 1, 2, 3, 4, 5. So here is a point, and it says that it's on the terminal side of theta. So what that means is if I drew an angle, initial side to the terminal side, this would be my angle theta. Find each of the 6 trig functions of theta. So to do this, what we're going to do is we're going to take our point and draw a line to the x-axis closest to the point. So just straight up or straight down to whatever that x-axis is. And I'm going to use this right triangle and this angle theta inside next to my origin as my reference angle. We're going to call it a reference angle. And then I can use my Pythagorean theorem to find the radius. So this is a length of 3 and in the negative direction. This vertical length here is -5. And if I do -3 squared plus -5 squared equals c squared, I can solve for my radius. So let's see, that's 9 plus 25 is c squared. C is the square root of 34. And 34 does not reduce, it's 2 times 17, so I can't simplify that at all. So now that I have my triangle, notice the radius is not 1. So I can't just say that the cosine of theta is the x value. I have to divide that x by the radius. So we have, let's see, sine of theta, cosine of theta, tangent of theta. It wanted the 6 trig functions, so that means I also want the reciprocal functions, cosecant of theta, secant of theta, and cotangent of theta. And then remember, we're just using SOHCAHTOA to get these values. So sine of the angle, which remember we're going from this angle here, is opposite over hypotenuse. So we get negative, I wanted that to be my black pen, -5 divided by the square root of 34. And then we want to rationalize that. So again, we're going to multiply by the root 34 over root 34. Let's see if I can make this bigger. There we go. And I get -5 square root of 34 divided by 34. I'm not going to show the multiplication step anymore when I rationalize the denominators. I'm just going to jump to the resulting piece. So cosine is adjacent, -3 divided by the hypotenuse, root 34. So rationalize that, we get -3 root 34 over 34. Tangent is opposite, -5 divided by adjacent, -3. I do want you to simplify that negative over a negative to show that the tangent is positive. We're in the third quadrant. Cosecant is the reciprocal of the sine. And remember, if we take the initial fraction and flip it over, square root of 34 over -5, then we don't have to rationalize it again. So kind of go back to the original one. Secant is the reciprocal of the cosine, so root 34 over -3, and cotangent is going to be the reciprocal of the tangent, so we end up with 3/5. All right, next example. We have the quadrantial angles. So I mentioned this term yesterday in the unit circle lesson, but the quadrantial angles are the angles at, here, I'll draw a graph for these. So we get 0, 90 degrees, 180 degrees, and 270 degrees. And then, of course, we also want to make sure we're practicing our radians. So 0, pi over 2, pi, and 3 pi over 2. And then these are what we call the quadrantial angles. And we want to evaluate the sine function and the tangent function at each one of these. So sine and tangent. And then I also said also find the cosine. So let's look at I'm going to erase that there. Cosine. So sine of 0, and I'm going to use radians here. The sine of pi over 2, sine of pi, and sine of 3 pi over 2. So here we aren't given any information about the radius, so we can assume the radius is 1. So if I drew a circle around here, these points here, this would be 1, 0. This one would end up being 0, 1. This would be -1, 0. And this one would be 0, -1. And assuming r is 1, my sine is the y value. So the sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. And sine of 3 pi over 2 is -1. These are actually the points we're going to use when we start graphing our trig functions later. Cosine of 0, cosine of pi over 2, cosine of pi, and cosine of 3 pi over 2. We get cosine of 0 is the x value divided by our radius, which is 1, so we get 1. Cosine of pi over 2 is 0. Cosine of pi is -1. And 3 pi over 2 is 0. And then our tangent of 0, tangent of pi over 2, and 3 pi over 2. So tangent, remember, is y divided by x. So if I take the tangent of 0, I have 0 divided by 1, which is 0. If I take the tangent of pi over 2, I have 1 divided by 0, which is undefined. We're actually going to end up having asymptotes on our tangent graph. Tangent of pi is 0 divided by -1, so that's 0. And tangent of 3 pi over 2 is -1 over 0, which is undefined. So tangent gets a little funky. Okay. Next piece, so we talked about this again on the unit circle. So a fun way to remember which trig functions are positive is all students take calculus. And what that means is in quadrant 1, all functions are positive. In quadrant 2, the sine and its reciprocal function, the cosecant, are positive. In quadrant 3, the tangent and its reciprocal function is positive, and then we get the cosecant and its reciprocal, the cosine and its reciprocal, the secant, is positive. So all students take calculus. All right, let's look at the next page here. So find the quadrant in which the angle lies. So here we get little kind of puzzle problems, and make sure you know which quadrants are which. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if the tangent is negative and the cosine is positive, name the quadrant in which the angle lies. So if the tangent is negative, I'm going to be either here or here. Because if you remember, everything's positive here. All students take calculus, and the tangent is positive, So I can kind of here. The tangent is positive here and here, and it's negative here and here. And this says negative. All right, and then we want the cosine to be positive. All students take calculus. If the cosine is positive, then it's positive here and here, and negative here and here, which means I want either this one or this one. So now you have to think about the quadrants that overlap for both of them. This one works for both pieces. So that's going to be the quadrant that my angle is going to be in, because that's the one that works for both. If you wanted to pause the video now and try example B, and then check your answers with me, that would be good. All right, so sine is negative. So all students take calculus. The sine is positive in quadrants 1 and 2. So the sine is negative here and here. And then the cosine is negative. Let's see, we'll use green. Cosine is negative here and here. So which quadrant do they both work for? They both work for quadrant 3. So my answer is quadrant 3. The reason we're doing these problems is because every time I tell you something, you'll see in this next problem, we actually have 2 quadrants that it could work for, and we have to kind of narrow it down sometimes so we don't have 2 answers. All right, so for example, if the tangent is negative 2/3, there's actually 2 ways that can happen. The tangent is negative here and here. So, and the tangent, remember, is y over x. So I could draw an angle here where my values are negative, let's see, that would be positive 2 for the y and negative 3 for the x. I'd get a tangent of negative 2/3. Or I could have drawn an angle here where my x value is positive 3 and my y value is negative 2, I'd get a tangent of negative 2/3. So now we have to decide which one they want, and that's where this piece here is going to come in. Probably should have made this green. Okay, so if the cosine has to be positive, you have to think, okay, which one of these are we going to have a positive cosine? So all students take calculus between quadrants 1 and 4. The 4th quadrant is where my positive cosine is going to be. So that means I want to be in the 4th quadrant. I'm not going to be in the 2nd quadrant. And I need to find the cosine and the cosecant, cosine of theta, and so remember this is x over r. And the cosecant of theta is the reciprocal of the sine. So the sine is y over r, so the cosecant is going to be r over y. So we've got x, we have y, but we don't have the radius here. We do need to figure out that using our Pythagorean theorem. So let's see, we've got 3 squared plus negative 2 squared equals all r squared. 9 plus 4. So we get the square root of 13. So my hypotenuse is the square root of 13, or my radius is the square root of 13. So the cosine of that angle, so we're going from this angle in here, always next to the origin or connected to the origin. The cosine is going to be the x value, which is positive 3, divided by the square root of 13, and then we have to rationalize that, 3 root 13 over 13. Ooh, my work's kind of running into itself. All right, and then the cosecant is the radius, square root of 13, divided by the y value, which is negative 2. And I really like putting the negatives on the graph where they go so that I don't have to then think about whether or not that thing is positive or negative. It just kind of happens for me. If I didn't tell you that the cosine was positive, then we could have been in quadrant 2 or 4. We wouldn't have known exactly where that angle would have been, and my cosecant and my sine would have switched signs. So like the cosine would have ended up being negative, the cosecant would have ended up being positive. So it will switch our signs if we're not sure which quadrant we're in. All right, moving down, reference angle. I've actually used this term once already. So the reference angle is the angle, positive acute angle formed by the terminal side and the x-axis. So wherever you are, you're going to draw a line up to the x-axis or down to the x-axis. So like this, wherever you are. And then that angle inside that triangle next to the origin is your reference angle. So let's find some reference angles here. If we graph 345 degrees, remember this is 270 degrees and 360 degrees. So it's somewhere in here. It doesn't matter if it's exactly where it's supposed to be or not. I don't care. So here is 345 degrees, but the reference angle is going to be this angle in here. And we use a little theta prime. Sometimes I forget the prime. It's okay. Try to remember the prime. So now to figure that out, if I went 345 degrees all the way to here, and if I had closed it up, it would have been 360. I just need to do that subtraction. So what's the difference between 360 and 345? How much more do I need to go? And that difference is 15 degrees. So my reference angle, theta prime, is 15 degrees. All right, switching over to radians here. Ooh, that is not where I drew that line. Okay, so 5 pi over 6. So remember, 5/6 is a little less than 1, and 1 pi is here. Pi over 2, half of pi is here, and 5/6 is more than, oh, I am running into my problem, sorry, is more than a half. So let me clean this up a bit. So this is kind of how I figure this out. So 5/6 is less than 1 and more than a half. So I know that I'm less than 1 pi, but more than half a pi. So I'm somewhere in here for my angle 5 pi over 6. So here is 5 pi over 6, but I don't want that angle. I want this angle. There's my reference angle. And the reason why we're learning this is because when we make our triangles and we figure out our SOHCAHTOA for our trig, we always use the reference angle. So my angle theta prime, my reference angle, is the difference between 5 pi over 6 and pi. Now, if we think about pi as a fraction over 6, it would be 6 pi over 6. So the difference between 6 pi over 6 and 5 pi over 6 is 1 pi over 6. Or you could have just done pi minus 5 pi over 6 and then make pi over 1, and you need a common denominator when you subtract fractions. So that's another way to kind of figure that out. You get 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. All right, next example. We have negative 135 degrees. So remember, negative angles go clockwise. So it goes this way. And let's see, negative, so this would be negative 90 degrees. This would be negative 180 degrees. And so negative 135 degrees is going to be somewhere in there, negative 135 degrees. Now the reference angle, again, we make a line straight up or down to our x-axis, and our reference angle is right in there, theta prime. And our reference angle, if you look back up at the definition, it always has to be a positive acute angle. So I don't want to give a negative value here. I want to give just the positive difference between 180 and 135. So 180 minus 135 is going to be 45 degrees. So my reference angle, theta prime, is going to be 45 degrees. So you just kind of take the negative pieces out of it once you figure that out. All right, and then the last one seems a little weird. 2.5, notice there's no degrees, not degrees. It's just radians. I know it's not in terms of pi, but remember, pi is just a number. If we multiply something by pi, we get a decimal. So 2.5, we kind of have to think about what are the values of pi as numbers. So if this is 3.14, instead of writing pi, and half of pi, if I take pi divided by 2 on my calculator, I get 1.57-ish. Then 2.5 is kind of in the middle of that-ish, somewhere. So this is the angle 2.5. That's why radians are so nice, because they're just numbers. They're not anything special. So now our reference angle here, angle theta prime, is going to be 3.14 minus 2.5, and we get 0.64 as our reference angle. All right, so that's what a reference angle is, and we are definitely going to be using those a lot in this chapter. So these are just kind of more problems for you to practice with. If you want to pause the video and try them yourselves, I'm going to go through these a little faster here. So 580 degrees, the difference between this and the other ones is this is more than one revolution. So what we want to do first is take 580 degrees and subtract a revolution out of it. So 580 minus 360 gives us 220 degrees. So we just want to get it down to kind of one circle there. 180 degrees, 270 degrees. So 220 is going to be in there. So this is 220 degrees. My reference angle is going to be this value here. So I want to figure out, if I went 220 degrees, what's the difference between 220 and 180? And I get 40 degrees. So that's my reference angle. Similarly, 8 divided by 3 is more than 2. So I can take 8 pi over 3 and subtract 2 pi over 1. I want a common denominator. So that's 8 pi over 3 minus 6 pi over 3. And I get 2 pi over 3. So now we want to figure out where's 2 pi over 3. You can look at your unit circles at this point if you want. Pretty much once you memorize the unit circle, you can then use it to your advantage. And 2 pi over 3 is on the unit circle. So 2 pi over 3 is here. So, and then this is pi, or you can think of it as 3 pi over 3. So this reference angle, theta prime, is pi minus 2 pi over 3. Get a common denominator, and I end up with 1 pi over 3 for my reference angle. All right, and then the last one here, we have negative 13 pi over 6. So I want to add 2 pi to this as many times as it takes to get this thing to be positive, so I know where it is. Again, common denominators. So really, I'm taking negative 13 pi over 6 and adding 12 pi over 6, and I get negative 1 pi over 6. And actually, I'm not going to get this thing to be positive, because if I use what I know about negative angles, it goes this way, that much, pi over 6. So that's negative pi over 6. And then if you think about what a reference angle is, it's the angle measure of that. So really, my reference angle is pi over 6. So this one's kind of easier if you don't make it positive first. But you can if you want. All right, example 7. We are almost done here. Use reference angles to find the exact value of each of the following trig functions. So now we're going to bring in our trig functions, not just our angles. So the sine of 135 degrees. So we want to, I always draw this, you know me, I like drawing things and getting a visual of what I'm seeing. So 135 degrees is in this quadrant. If I take 180 minus 135, I get 45 degrees. So that means the reference angle is 45 degrees. Now, saying that I want the sine of 45 degrees, we have to be a little bit careful. I am in quadrant 2. So I also need to think about whether or not the sign is positive or negative in quadrant 2. So if we use our all students take calculus, I know that the sign, which is what I'm finding, is positive. So I can literally just think about, okay, what's the sign of 45 degrees? You can use your unit circle page if you want. I get square root of 2 over 2, and I know that it's positive in quadrant 2, so I'm going to use the positive value. All right, the next one, we have the cosine of 4 pi over 3. So where is 4 pi over 3? It's more than 1, so it's more than a pi. This is 4 pi over 3, which means when I draw my reference angle, I get pi over 3. So you can kind of think of this as finding the cosine of pi over 3, but we need to think about our all students take calculus. Notice the cosine in quadrant 3, the cosine of the angles is negative. So when I think about what the cosine of pi over 3 is, which the cosine of pi over 3 is 1/2, cosine of pi over 3 is 1/2, my cosine of 4 pi over 3 is going to be negative 1/2 because I'm in that quadrant where the cosine is negative. All right, and last one, cotangent of negative pi over 3. So again, I'm going to use that negative angle to my advantage. Negative pi over 3 goes this way, pi over 3 units. So I can think of this as the cotangent of pi over 3, which is the reciprocal of the tangent of pi over 3. So I get 1 over square root of 3 rationalized to root 3 over 3. But all students take calculus. Ask yourself, is the tangent and the cotangent positive or negative? In that fourth quadrant, you find that it is negative. So my cotangent of negative pi over 3 is negative root 3 over 3, because I know I'm in the fourth quadrant where the tangent and cotangent are negative. All right, last examples. So same kind of thing, but we're going to go multiple revolutions. So I want to take 14 pi over 3 and subtract 2 pi to get this thing a little bit more manageable, get a common denominator. 14 minus 6 is 8 pi over 3. I can subtract 2 pi again. Common denominator. 8 minus 6 is 2 pi over 3. So that's where I'm going here. If I did that right. Yes, okay. So 2 pi over 3 is here. 2 pi over 3. So notice this is a coterminal angle, which we learned before. And it's easy to get coterminal and reference mixed up. So this 2 pi over 3 and actually 8 pi over 3, these were coterminal angles to 14 pi over 3. They are not the reference angle. The reference angle is the angle that you get here between where you are and the x-axis. So my reference angle, theta prime, is positive pi over 3 because that's the amount of space I have there in my triangle. So be careful about coterminal versus reference angles. All right, and I'm trying to find the tangent. So the tangent of pi over 3 is the square root of 3. And I want to think about, okay, what about my sines? All students take calculus. My tangent is negative in that quadrant there. So my tangent of 14 pi over 3, I like to rewrite it as the original problem. If I'm going to rewrite the whole thing, it's going to be negative. All right, and then the last one, secant. Remember, secant of theta is 1 divided by the cosine of theta. You do need to know your reciprocal functions. Negative 17 pi over 4. If I add 2 pi, get my common denominator. I'm going to have, 8 pi. No, I don't. Sorry, losing my myself here. 17, negative 17 plus 8 is what? Oh, geez. Negative 17 plus 8. I don't trust myself right now. Negative 9 pi over 4. I'm going to add another 2 pi over 1, which is 8 pi over 4. I get negative pi over 4. Okay, so I'm going to use that negative angle. I know that pi over 4, negative pi over 4 is here. So my reference angle is pi over 4. My secant is 1 divided by the cosine. The secant of pi over 4 is the square root of 2. And then I want to think about my all students take calculus, the cosine, and thus its secant is positive in that quadrant. So there we go. And we're done.